We physicists have held up 100 years, starting around 1916, for this photo. It is a district where dark openings may very well be one of the most intriguing and secretive peculiarities in the universe. They are huge monsters as far as power, and yet practically imperceptible to us. A dark opening gauging maybe 2 to 4 million times the mass of the Sun may be one of these. As a result of the examination contributed over the last years, we have gone from knowing literally nothing about them to finding out increasingly more, very close and individual. Keeping in mind that things have simply gotten more insane, Kaku has declared that we at long last got to check what's back to front. A dark opening. This new data sheds light on subtleties the universe of science could have missed from the start. Go along with us as we dig further into dark openings and divulge what's inside. Space is immense. However, what are dark openings? Before we dive into the subtleties of what Kaku tracked down, we need to examine the nuts and bolts. Albeit most of us have some thought of what dark openings are, there are still holes in our grasping. In 1916, Albert Einstein published his hypothesis of general relativity, which anticipated the presence of dark openings. Around then, the idea was absolutely hypothetical. It took another 50 years for established researchers to track down proof of their reality, which occurred during the 1960s. Specialists examining the Cygnus group of stars saw a strangely radiant blue star discharging X-beams. This star wasn't stale. It was circling a Goliath dark object. Upon additional examination, it was observed that the X-beams were being sucked into this item. Hence, the term dark opening was begot. This disclosure was critical because it demonstrated that dark openings were not only an illusion of Einstein's creative mind, but a genuine substance in space that we earnestly needed to find out about. Scientists around the world began to concentrate on this dark opening named Cygnus X1, situated in the Cygnus heavenly body, around 6,000 light-years from Earth. It was multiple times more brilliant than the Sun and amazingly thick, with such a solid gravitational pull that not even light could escape from it. Therefore, it is known as a dark opening. The idea of a dark opening is both interesting and unnerving. A locale of space where gravity is so solid that nothing, not even light, can circumvent. Whatever gets excessively near a dark opening won't be maneuvered into it ever to be seen again. This peril makes it considerably more critical to learn everything there is to be familiar with them. Later finding Cygnus X1, researchers began looking for other dark openings and found there might be nearly more than 100 million dark openings in the Milky Way alone. In light of the fact that they are so unimaginably difficult to identify, we still don't have a precise number. By the by, it shows up there are a few million dark openings in our very universe, making them significantly more vital to concentrate on. The principal worry with dark openings is generally gravity. Their gravitational force is extraordinary to such an extent that anything entering it packs down cosmically until it turns into a peculiarity. In less complex terms, dark openings resemble inestimable vacuum cleaners that suck everything in. Quite possibly the most unnerving part of dark opening exploration is that if somebody somehow managed to fall into one, they would be extended into a solitary line. This interaction would happen gradually, and the individual would kick the bucket before the last structure sets in. So how about we simply say nobody ought to step into one? Anyway, since they are all over, might we at some point truly be in harm's way? Notwithstanding the nearest dark opening being 500 light-years away, it is still close enough to bring up issues and concerns. In 2021, researchers had the option to deliver the first clear photo of a dark opening, specifically the M87 dark opening. This dark opening was captured over several evenings in succession, and with each photo, the scientists assembled more proof. They needed to fasten the individual photographs together to make a complete picture, uncovering that there are 3 layers to a dark opening. It's not only one single expanding opening of nothingness, as many individuals accept. The cycle includes enduring the initial 2 layers prior to arriving at the nothingness part. The first layer is known as the event horizon. When you pass this point, there is no turning around. You will be sucked into the dark opening. The subsequent layer is the photon sphere, where light circles the dark opening. Any light entering this district will be caught and incapable to get away from the dark opening's gravitational pull. At last, we come to the third layer, the singularity. This is where all that enters the dark opening gets packed until it turns into a singularity. A point in space-time where the laws of physics, as we probably are aware them, separate and we can't foresee what occurs next. The density at the singularity is boundless, and the laws of physics stop existing. What makes all of this vastly more terrible is that every single dark opening studied will be altogether not quite the same as the last. They will quite often follow a similar three-layer idea, yet the manner in which they function can be incomprehensibly different. Typically, studying such singularities would include bouncing back on telescopes and seeing exhaustively, yet with dark openings this isn't plausible. Researchers can concentrate on dark openings by implication, by noticing the radiation they emanate and the gas and dust encompassing them. Sending a probe like Voyager into a dark opening is inconceivable, since anything that enters the event horizon is pulled towards the singularity, where it is compacted to an boundlessly little point. Accordingly, we can't squander billions of dollars on probes that would simply be squashed into nothingness. Researchers are left with no decision except for to concentrate on these items in a two-dimensional way, despite the fact that they are three-dimensional peculiarities. To make matters significantly more challenging, each dark opening is extraordinary, and the laws of physics separate while investigating within. This implies customary strategies for logical request don't actually apply to dark opening investigations. However, scientists haven't been inactive. There are quite a large number of hypotheses and clarifications about dark openings. One convincing hypothesis is that they are made from falling stars. At the point when a star depletes all its fuel, it can never again produce sufficient energy to balance gravity, making it collapse in on itself and possibly turn into a singularity. To comprehend the nature of dark openings top to bottom, NASA researchers directed their concentration toward the center of the galaxy. M87 astronomers noticed a strong whirlpool of very hot hydrogen gas turning at a shocking pace of 1.2 million miles per hour. The sheer power of the turning plate of gas ought to have made it fly apart, yet it didn't. Researchers reasoned that an epic mass gathered at the focus of the galaxy kept this from happening. This monstrous object, weighing as much as 2 to 3 billion suns, could just be a dark opening. However, that is not the only hypothesis. In 1963, New Zealand mathematician Roy Kerr utilized Einstein's conditions to depict a turning dark opening, suggesting that it wouldn't implode into a point but maybe structure a ring of fire or a slight circle. This turning plate of matter, called the ergosphere, is the district encompassing the dark opening where the laws of physics begin to separate. Kerr's equation, moreover, anticipated the presence of an Einstein-Rosen bridge or wormhole, a hypothetical entry through space-time that associates two separate districts of the universe, or indeed, even two parallel universes. Assuming one were to fall into a dark opening, rather than being squashed, they may be sucked down a passage through the ring of fire and shot out of a white hole in an equal universe. To figure out how this functions, consider the concept of space-time in Einstein's hypothesis. Existence is interconnected, forming a four-dimensional texture called space-time. Objects with mass twist this texture, creating a gravitational field that makes different objects move towards them. Envision a piece of paper addressing space-time. On the off chance that you place two focuses on the paper and define a boundary between them, it represents how objects travel through space-time. If you could overlap the paper in half to create a shortcut between the two focuses, this represents a wormhole, an easy route through space-time that associates two far-off focuses in a flash. Wormholes aren't simply a science fiction idea. They are a prediction of general relativity. Albeit nobody has noticed one straightforwardly, wormholes are innately unsound and would implode very quickly. The presence of an Einstein-Rosen bridge would mean dark openings are not simply grandiose vacuum cleaners but could likewise be gateways to different locales of space-time. Might we at some point use a wormhole to go through space and time? Sadly, the response is likely no, not yet. Regardless of whether we could stabilize a wormhole, it is improbable we could utilize it to travel quicker than light. Einstein's hypothesis of extraordinary relativity predicts that the speed of light is an outright breaking point on how quick anything can go through space-time. Regardless of this, the hypothesis of wormholes and dark openings as pathways to different pieces of the universe or various times has intrigued physicists for quite a long time. The thought of alternate routes through space-time, permitting traversal significant stretches or into the past, could be revolutionary if attainable. The Kerr wormhole, named after Roy Kerr, is quite possibly of the most charming idea in this field. It is a speculative passage through space-time that could interface two far-off focuses, like various universes or different times within a similar universe. The mongrel wormhole is ring-shaped, like the mirror in Alice in Wonderland, where going through it could possibly transport a voyager to one more universe or time with various actual regulations. While the possibility of wormholes as methods for interstellar or time travel is energizing, it is also dubious. A few physicists contend that wormholes, especially dog wormholes, may be temperamental or difficult to cross because of extreme radiation and subatomic forces. Pundits call attention to that Einstein's conditions used to depict wormholes and dark openings only work for gravity and not for the quantum forces that govern radiation and subatomic particles. To genuinely comprehend these peculiarities, another hypothesis is required that joins gravity with quantum hypothesis, a hypothesis of everything that consolidates Einstein's hypothesis of gravity with quantum hypothesis. Michio Kaku, a prestigious hypothetical physicist, has been working on a hypothesis of everything for a really long time. The main promising competitor is superstring theory, which joins gravity with quantum hypothesis. It suggests that subatomic particles are minuscule vibrating strings and that the universe is an orchestra of these strings. Similarly, as different melodic notes relate to various vibrations of a violin string, various particles in nature correspond to various vibrations of a superstring. Superstring theory likewise makes sense of numerous strange peculiarities by demonstrating that as strings travel through time, they twist the texture of space, producing dark openings, wormholes, and other outlandish answers for Einstein's situations. Anyway, the additional elements of spacetime expected by superstring theory are little to the point that we can't study them straightforwardly. The most exact estimations in our research facilities, as it were, utilize the four elements of spacetime. We know all about length, width, profundity, and time. How might we know the extra aspects exist? One chance is that these aspects are nestled into firmly, that they are undetectable to us, like a piece of paper firmly rolled into a chamber. If you were an insect strolling on the paper, you could not notice the bend. Correspondingly, the extra aspects of spacetime in superstring theory could be nestled into small circles or twistings that are imperceptible but influence the behavior of the strings vibrating in them. Another chance is that these additional aspects were more noticeable at the universe's start, during the Big Bang. From certain perspectives of superstring theory, the universe began in a condition of 10-dimensional spacetime, with all aspects similarly apparent. As the universe expanded and cooled, the extra aspects began to fold and twist up, leaving us with the four aspects we notice today. If this is right, we could identify hints of the extra aspects around us. The science associated with superstring theory is amazingly intricate and has opened new areas of math. However, tackling the issue of a quantum dark opening has demonstrated tricky. While numerous physicists have attempted, nobody has yet succeeded. Edward Witten of the Institute for Advanced Study at Princeton has called superstring theory 21st century physics that fell unintentionally into the 20th century. Last year, a few physicists freely reported a critical advancement. String theory could totally tackle the issue of a quantum dark opening, albeit just in two aspects, not 10. Many believe it's only a matter of time before somebody breaks this issue. Up to that point, it's still too early to anticipate intergalactic or time travel endeavors. With this, one thing is clear: there are just an excessive number of questions and, surprisingly, more potential arrangements. Michio Kaku's string theory adds another twist. Maybe the Big Bang wasn't as gigantic as normally thought. It wasn't a monstrous blast or a boisterous commotion as one could anticipate. The theory of the primordial cosmic explosion doesn't explain what caused the alleged bang or how it happened. It just states that it happened. We really want a hypothesis that represents what occurred before the Big Bang. String theory proposes that our universe could have shaped from the impact of two separate universes or risen up out of another universe, like a child being brought into the world from its mother. This association between universes is known as a wormhole, likened to a cylinder interfacing two bubbles. We might have previously found proof of this umbilical rope associating our universe to one more. In a way, we could be living inside a dark opening, ignorant, in light of the fact that we exist in four aspects and can't see past them. It's possible we are in a dark opening, and the dark openings we study are wormholes to different aspects.